As Michio Kaku often reminds us, science advances when the impossible becomes undeniable. And right now, something in our solar system is forcing us to face exactly that. The interstellar object, the 3I Atlas, already infamous for its mysterious deceleration and hollow interior, has just doubled in size in a single week. Between October 12th and 19th, 2025, observatories in Europe, Hawaii, and Chile all measured the same result. 23 kilometers became 46, a 100% increase, a phenomenon that no known physical law can explain. Comets don't grow, they sublimate, shrink, and break apart. But this one expanded and smoothly, symmetrically, and in defiance of basic thermodynamics. So what are we really witnessing here? A measurement error? A new kind of natural process? Or a controlled structure, deliberately reconfiguring itself for a specific purpose? If that's the case, then this isn't just an astronomical anomaly. It's a turning point in our understanding of the universe, and perhaps of who else might be sharing it. When asked about 3I Atlas, Michio Kaku didn't rush to declare discovery or disaster. He simply said that science begins where certainty ends. That phrase now hangs over every observatory on Earth, because what astronomers have measured is, by all accounts, impossible, and yet the data refuse to be ignored. Kaku's position is cautious but not dismissive. He knows how revolutionary ideas are born, not from wild speculation but from persistent anomalies that refuse to vanish under scrutiny. The doubling of 3I Atlas's size is precisely such an anomaly. It defies thermodynamics, material science, and orbital mechanics all at once. That's why silence in this case is not avoidance, it's preparation. Behind the public calm, research centers are rechecking every frame of data. Was there an imaging artifact, a sensor glitch, atmospheric distortion? Each hypothesis is tested, discarded, then tested again. The consensus so far is uncomfortable. The readings are real. Kaku's restraint reflects that tension between disbelief and verification. For decades, he has warned against the premature leap, announcing paradigm-shifting claims before evidence can survive the full cross-examination of science. But he also reminds us that denial is no safer. If something violates the known laws of physics repeatedly and predictably, those laws must expand. Atlas has placed us exactly at that threshold. The responsible response is not silence, it's disciplined curiosity. This measured attitude has historical weight. When pulsars were first detected in 1967, astronomers labeled them LGM for little green men, a joke masking genuine confusion. Only later did we understand their true nature. Kaku cites that episode as a lesson. Anomalies are gateways, not verdicts. 3I Atlas could follow the same path, from absurdity to discovery. Still, the unease remains. Every institution that confirms the measurements also hesitates to interpret them. That hesitation is telling. It signals the possible birth of something extraordinary. Kaku calls it the silence before a paradigm speaks. And if he's right, that silence may soon be broken. At first, the numbers looked like a glitch, an outlier in an otherwise stable data set. On October 12, 2025, the European Southern Observatory, the Gemini Observatory, and NASA's Infrared Telescope Facility each logged 3I Atlas at roughly 23 kilometers in diameter. By October 19th, the same instruments, using the same calibration, recorded 46 kilometers. The readings aligned perfectly across continents and wavelengths, and suddenly every assumption about the object's nature was in question. NASA's Jet Propulsion Laboratory received the compiled data late that weekend. According to internal sources, the first reaction wasn't excitement, it was disbelief. Analysts reprocessed the imaging sequences line by line, searching for computational errors. They found none. The instruments were clean, the algorithms solid, the expansion real. That left physicists staring at a contradiction that no natural model could resolve. A comet's nucleus cannot double in size. Sublimation, the process that creates a comet's tail, strips material away. Expansion implies the addition of matter or the movement of internal structures outward. Neither mechanism exists in the standard model of comet behavior. Cross-verification began immediately. Infrared readings confirmed that the object's heat signature had changed subtly, consistent with a larger, more reflective surface. Optical and ultraviolet data matched the new dimensions. Even the polarization patterns of reflected light suggested a different geometry. It wasn't just a brighter halo, but the shape itself had transformed. Within JPL, the dataset was classified as Active Investigation Morphological Anomaly. That bureaucratic phrase hid the weight of what it implied. An object from another star system had altered its structure in real time. Every team involved, from orbital dynamics to material analysis, was instructed to recheck their instruments. None could find fault. Meanwhile, the broader astronomy community began whispering the same question. If this wasn't a measurement error or a visual artifact, what else could it be? An internal process, a massive release of volatile gases, a collapse and reformation event? Each explanation required physics we haven't yet observed. Each was less convincing than the next. By the end of that week, NASA quietly acknowledged the numbers in a short bulletin. Just one sentence noting unusual morphological changes under study. No conclusions, no theories, just confirmation that the expansion had occurred. In science, understatement often signals alarm, and in this case that silence spoke volumes. Something was happening out there that should not be possible. The laws of thermodynamics are not suggestions. They're the foundation of modern physics. Every engineer, every physicist, every student learns that heat makes solids expand minutely, not exponentially. Ice melts, vaporizes, and disappears. It never doubles in size. Yet between October 12th and 19th, 3I Atlas defied that most basic rule. It grew, not over eons, but in a single week. This is why scientists call it the thermodynamic paradox. When sunlight strikes a comet, it typically erodes its surface through sublimation, creating that familiar glowing tail. That process removes mass, shrinking the core slightly with every pass near a star. Atlas, instead, appears to have gained volume, a direct contradiction of energy flow and conservation principles. It's like watching an ice cube grow in the heat of a flame. To reconcile the data, some have proposed that what we're seeing isn't expansion, but optical illusion, a denser coma of gas and dust. However, the reflectivity, or albedo, of the observed surface tells a different story. The brightness is too consistent and the light too coherent for a diffuse cloud. Spectroscopy reveals solid reflection patterns, not gaseous scattering. The surface behaves as though it's metallic, or at least structured. That brings physicists to a painful crossroads. If the process is natural, it means there's a form of matter we don't yet understand, capable of expanding under heat without losing cohesion. If it's artificial, the implications are even greater: deliberate, controlled mechanical deployment. Either way, our textbooks cannot explain it. The models collapse under their own equations. Michio Kaku has described such moments as cracks in the wall of understanding. For centuries, those cracks have been where revolutions begin: relativity, quantum theory, dark energy. Each started as an observation that simply didn't fit. Atlas has become one of those cracks, widening daily, and physicists are watching it split the framework they built. The energy required for such an event is staggering. To expand a solid structure of that scale in a vacuum would demand forces far beyond what solar radiation alone can supply. If it's gas pressure, the object should have fragmented. If it's mechanical, it must have power and precision. The only consistent variable is intent, and that, more than the numbers, is what makes scientists uneasy. So the paradox remains unresolved. Matter doesn't appear out of nowhere. Energy can't reorganize solids without heat signatures or debris. Yet Atlas stands as proof that something, somewhere, is violating those principles in real time. And as Kaku himself once said, "When the data break the rules, it's the rules that must change." When the first expansion data emerged, the most reasonable idea came quickly. Maybe 3i Atlas was simply inflating like a cosmic balloon. The concept was elegant, even comforting. Trapped gases inside a hollow body could heat up as it neared the sun, building internal pressure until the surface bulged outward. A simple physical process, no aliens required. But almost immediately the numbers began to betray that hope. For a balloon-like expansion to occur, the object would need a flexible shell and massive amounts of trapped, volatile gases. Spectral scans, however, showed no sign of such materials. No methane spikes, no exotic hydrocarbons, no pressure release trails that would accompany rupture. In fact, the outer layer of Atlas remained spectrally consistent, rigid, not elastic. The balloon wasn't inflating, it was unfolding. Then came the timing. If this were pressure buildup, expansion would continue as solar heating intensified. Instead, the process stopped abruptly after reaching 46 kilometers across, as though the mechanism hit a programmed limit. Thermal models can't reproduce that behavior. A natural system doesn't know when to stop. It simply reacts until equilibrium or destruction. Even more telling was the absence of debris. A pressure-driven expansion of a solid shell should leave fractures, cracks, and loose ejecta detectable by radar or optical surveys. But the surface integrity remained stable. Infrared imaging showed no fragments or jets of escaping vapor. The shape didn't burst, it stabilized, smooth, and intact. Kaku has often said that nature doesn't fine-tune outcomes, it experiments blindly. What 3i Atlas did was the opposite of blind. Its change was precise, proportional, and symmetrical, within observational tolerance of less than 1%. That level of control implies constraint, not chaos. Whatever caused the growth behaved as if following instructions. The balloon theory lingers mainly because scientists need a natural explanation to test against. It's a placeholder, a model of last resort until better evidence appears. But in internal reports, researchers admit that it fails on every measurable front. It doesn't explain the timing, the uniformity, or the structural coherence. It's not just improbable, it's physically inconsistent. So the cosmic balloon joins a long list of theories that fit the comfort of expectation, but not the rigor of data. What's left is far more unsettling, a solid body that changed shape and size without breaking apart. That means the expansion wasn't inflation, it was deployment. And if that's true, the next question writes itself. Who or what built it to do so? At first glance, many astronomers hoped the apparent doubling of 3i Atlas was an illusion, a trick of light and dust. After all, comets often appear to grow as sunlight vaporizes their icy crusts, creating a bright coma that can span thousands of kilometers. Maybe, they reasoned, the nucleus hadn't expanded at all. Maybe we were only seeing a denser, more reflective halo of gas. That interpretation lasted less than 48 hours. Spectroscopic data quickly dismantled it. A comet's coma has a specific light signature: diffuse, low reflectivity, and highly polarized. Atlas didn't match that. Its reflectivity curve, or albedo, was consistent across multiple wavelengths, behaving like a solid surface rather than a cloud. The light bounced back as if from metal, not vapor. This wasn't a matter of resolution limits or visual distortion. High-resolution imaging from the Very Large Telescope confirmed a clean edge, a defined limb line inconsistent with the soft gradients of a gaseous envelope. Even the infrared heat map showed a uniform temperature profile across the expanded surface. That shouldn't happen in a transient coma. It happens on structured material, If the expansion had been purely optical, it would fluctuate with solar activity. But Atlas's size stabilized perfectly and its brightness pattern locked in place. No pulsing, no dispersal, no decay. In other words, whatever we were observing was holding form. A natural coma can't do that. It's constantly dissipating into the solar wind. Kaku once compared interstellar anomalies to messages in physics, the universe whispering that our assumptions are incomplete. Here, the whisper became a shout. A solid hull explains the data, a gas cloud does not. The structure's consistent reflectivity and thermal coherence make the coma illusion statistically impossible. Something physical, rigid, and cohesive must underlie the glow. The realization left a chilling implication. If the apparent expansion was, in fact, real structural deployment, it meant we were witnessing the mechanics of an engineered process, a system that unfolded itself in space, step by step, until it reached equilibrium. That interpretation doesn't just shift the conversation, it rewrites it. Because at that point, the question stopped being what happened and became who designed it to happen. By the end of that analysis cycle, most working groups quietly retired the coma theory. Publicly, the term morphological anomaly remained in NASA's statements. Neutral, vague, safe. But inside the data reports, the language hardened. The phenomenon was no longer described as optical. It was labeled structural. If 3I Atlas had simply expanded like a natural outgassing event, every part of it should have done so evenly. Solar heating acts uniformly across a rotating object, especially one tumbling slowly through interplanetary space. But that's not what the data show. Between October 15th and 17th, the northern hemisphere of Atlas expanded dramatically, while the southern remained largely unchanged. Nature doesn't do selective symmetry, engineering does. Dr. Sarah Chen from the KEK Observatory in Japan was among the first to notice. Her team analyzed the light curve differentials and found something stunning, a measurable asymmetry in the object's reflective pattern. The northern side brightened 37% more than the southern, and the change occurred within hours, not days. This suggested targeted activation, as if one half of the structure woke up first. That sequence simply doesn't fit known comet physics. Solar radiation should produce a gradient, not a divide. Uniform heating means gradual change. Uneven heating means surface texture or shading, not structural alteration. But the northern half of Atlas didn't just brighten, it physically expanded. Its radius increased, the geometry shifted, and its rotation stabilized instead of becoming chaotic. Something inside was compensating dynamically, almost as if by design. Infrared imaging supported the optical data. The northern region's thermal signature spiked briefly, then plateaued at a new equilibrium temperature. Exactly what you'd expect from a powered system completing a controlled motion. In contrast, the southern hemisphere showed no such spike. It remained inert, cold, and static. The division was surgical, not random. Engineers examining the data pointed to the possibility of segmented panels or layered compartments designed to deploy in phases. If Atlas were a constructed object, partial activation could explain the asymmetry. It might have opened one hemisphere first, perhaps to test stability or align with solar orientation. That would fit the timing perfectly, deployment followed by stabilization before full exposure. It's mechanical logic, not thermal chaos. Michio Kaku has often noted that in nature, randomness rules, in technology, pattern rules. The hemispheric expansion shows pattern, measurable, deliberate, sequential. There's no known natural precedent for this kind of behavior. It's not weathering, not sublimation, not magnetic stress. It looks like function, not failure. Still, the scientific establishment hesitated to draw that conclusion. Terms like differential thermal response and structural anisotropy filled the reports, linguistic shields for we don't know. But the asymmetry remains one of the most striking fingerprints of intelligent design in this case. If half of Atlas expanded on command, then the other half might be waiting for its turn, and that possibility changes everything. On October 16th at exactly 0347 UTC, a sudden burst of light flared from 3I Atlas, bright enough to be recorded by amateur telescopes across 3 continents. It lasted just over 4 seconds, then faded back to baseline. Within 6 hours, 2 more flashes appeared, each identical in intensity and duration. Observers in South Korea, Australia, and Chile all logged the same timestamps: 3 flashes, 1 object, no known natural cause. Initially, astronomers suspected cosmic rays or sensor artifacts, common culprits in high-sensitivity imaging. But the simultaneous timing across hemispheres ruled that out immediately. Different skies, different equipment, same event. These weren't random noise spikes, they were coordinated bursts of energy emanating from a single, moving source. Spectral analysis deepened the mystery. The flashes exhibited narrowband light. Wavelengths centered around 540 nanometers within the green visible range. Natural reflections scatter broadly, mechanical emissions don't. Whatever caused these pulses produced controlled, discrete frequencies, not diffuse solar glare. It was light behaving like signal, not accident. Some proposed that volatile jets, sudden releases of pressurized gas, might explain the phenomenon. But there were no corresponding shifts in trajectory, no visible debris, no rotational disturbance. A gas jet powerful enough to emit that much light would have nudged Atlas's path measurably. Instead, the object continued on course, steady and stable. That rules out explosive venting completely. Dr. Jennifer Park, the South Korean astronomer who first captured the initial flash, described it as too clean to be natural. Her imaging frames show sharp onset and sharp decay, no gradual fade, no diffuse halo. It was as if a switch had been flipped. In her report, she used a phrase that would echo through the community: mechanical precision. Those words changed the tone of the entire investigation. By the next day, monitoring networks began coordinating time-synchronized observations. No further flashes were recorded, but the pattern remained clear: 3 bursts, equally spaced, at the midpoint of the expansion phase. In engineering terms, that's the hallmark of activation, not randomness. It resembles test cycles, calibration routines, or energy discharges tied to a structural process. It's a pattern that speaks of control. Kaku has said that the universe doesn't do timing. Natural phenomena follow forces, not schedules. Only technology acts with rhythm and repetition. If those flashes were truly synchronized, they weren't byproducts. They were commands. And that means somewhere inside Atlas, something executed them. The moment 3I Atlas began to behave like a machine, attention turned to a familiar voice in the scientific world, Dr. Avi Loeb of Harvard. Loeb, already known for his controversial claim that Oumuamua might have been artificial, had proposed a framework years earlier. Interstellar craft could travel compact, then unfold once inside a solar system. At the time, it sounded theoretical. Now, with Atlas expanding in real time, it sounded predictive. The idea suddenly had evidence. Loeb's model describes what he calls collapsible architecture, a structure designed to minimize cross-sectional area during deep space transit, reducing damage from interstellar dust and radiation. Upon entering a system rich in starlight, it would expand, deploying sails, antennas, or instrumentation arrays. Such a system could use solar pressure for braking or steering, or harvest energy for onboard systems. In engineering terms, it's both elegant and efficient. Atlas's behavior fits that profile disturbingly well. It decelerated anomalously upon entry, rotated with improbable stability, then unfolded in stages. Each phase matched what a controlled deployment would look like in telemetry. Not a chaotic reaction, a sequence. The precision of that sequence implies planning, not chance. If the object were a manufactured probe, the doubling in size would make sense as a design feature, not a violation of physics. The expanded surface area could function as a solar sail or a power gathering array. The internal hollowness, previously dismissed as an anomaly, would instead represent storage space for retracted components. What appeared as a mystery becomes, under Loeb's model, logical engineering. Form follows function, even at interstellar scale. Kaku has often said that advanced technology is indistinguishable from natural law rewritten. That sentiment resonates here. What we call impossible might simply be unfamiliar engineering. To a civilization older by 1,000,000 years, folding and unfolding spacecraft could be routine, like an umbrella opening in sunlight. Atlas, then, may be less comet and more construct. Still, Loeb's hypothesis remains deeply controversial. Many astrophysicists reject it as premature, arguing that extraordinary claims require extraordinary evidence. But as the data mount, the burden of proof is shifting. Natural explanations are running out of space. Artificial ones are fitting better with every measurement. Whether Atlas is a functioning probe, a derelict relic, or something else entirely, the concept of collapsible design now defines the debate. And if this truly is a machine unfolding before our eyes, it means interstellar engineering isn't theoretical anymore. It's visible, measurable, and already here. As data poured in from around the world, the debate within the scientific community split cleanly into two camps. On one side were those arguing for a natural process, internal pressure building up inside a porous shell until the structure swelled outward. On the other were the growing number who believed the evidence pointed toward active control, mechanical reconfiguration directed by an internal system. Both sides had data. Neither could fully explain what they were seeing. The pressure hypothesis seemed plausible at first glance. If volatile gases were trapped within a hollow interior, sunlight could heat them unevenly, forcing the shell to bulge or fracture. But the problem was consistency. A pressure event should look violent, irregular expansion, surface cracks, fragments trailing behind. None of those signatures appeared. The expansion was steady, proportional, and stopped at a precise limit. The control hypothesis, by contrast, fit the timing too well to ignore. The expansion occurred in 3 discrete phases, each separated by roughly 48 hours, as if responding to a programmed sequence. Infrared emissions spiked at the beginning of each phase and stabilized immediately after, exactly like a system drawing and then balancing power. It wasn't explosive, it was procedural. That word alone changed the tone of every internal report. NASA's analysts tried to quantify the odds of such coordination occurring naturally. Their estimate was vanishingly small, less than 1 in 10 million based on known comet dynamics. Even a rotating object under differential heating couldn't reproduce the rhythmic symmetry observed. The probability that 3I Atlas was acting under instruction, however metaphorically, was no longer zero. And in science, zero is sacred ground. Kaku warned that scientists often choose the least impossible explanation rather than the most probable truth. That sentiment echoed through research circles as pressure models collapsed under the weight of precision data. The object wasn't leaking or reacting, or it was behaving. It exhibited boundaries, intervals, stabilization, the hallmarks of feedback control. Nature doesn't fine-tune itself this way. By late October, a new consensus began to form quietly, though not yet publicly. If internal pressure were the cause, expansion would continue as solar heating intensified. But the growth had stopped, as if a command had been executed and completed. The data suggested not instability but finalization. Something had reached its intended configuration. The scientific dilemma is now philosophical as well. If an object behaves like it's controlled, do we treat it as a machine until proven otherwise, or dismiss the pattern until it repeats? The stakes of that question are enormous, because if external control is real, then for the first time in history, we are witnessing the deliberate actions of technology not made on Earth, and it's still moving. If 3i Atlas truly reconfigured itself, the next question is both obvious and unsettling. Why? No machine acts without purpose, and no expansion of this magnitude would occur without reason. Physicists and engineers now find themselves asking questions once reserved for science fiction. Was it collecting energy, preparing to maneuver? Or was it opening its eyes? The first and simplest possibility is solar collection. By doubling its diameter, Atlas increased its surface area eightfold, ideal for harvesting sunlight through photovoltaic or reflective means. That energy could power instruments, propulsion systems, or onboard sensors. In spacecraft design, area equals capability. More exposure means more control. Another theory focuses on deceleration. If the structure expanded to catch solar radiation, it could use photon pressure to slow its velocity, functioning as a massive solar sail. This would explain its earlier anomalous deceleration, previously deemed impossible. The sequence of events, decelerate, stabilize, expand, fits the logic of a deliberate braking maneuver, not reaction, but navigation. A third idea is communication. The expansion might have deployed antenna arrays or reflective panels designed for signal transmission or data relay. The synchronized flashes observed earlier could have been system tests or calibration bursts. If the object is transmitting, it might already be sending information back to its origin point. The question then becomes, who's listening? Kaku has long argued that any Type 2 civilization capable of harnessing stellar energy would design probes that operate autonomously, powered by light itself. What we may be observing, he says, is engineering so advanced it mimics life. The ability to self-repair, self-deploy, and self-adapt are hallmarks of biological systems. Atlas could represent that convergence. Technology functioning with the logic of evolution. Not alive, but behaving as if it were. From an energy perspective, the event remains baffling. The power required to move that much mass precisely and symmetrically exceeds what a small comet nucleus could generate naturally. It implies internal energy storage, conversion mechanisms, or even propulsion systems integrated into the structure. No natural material we know could endure such stress without fracturing. Yet Atlas endured and completed its transition. Intent, however, is the hardest thing to infer from data. Is this expansion a response to sunlight, a routine system cycle, or a deliberate preparation for something yet to come? If it's the latter, the next logical step might involve interaction with solar radiation, with nearby planets, or with us. Because once something acts with purpose, it's no longer just an object. It's an agent. Timing in nature is usually messy. Comets flare unpredictably, solar winds vary, orbital shifts take years to show pattern. But 3i Atlas doesn't seem to obey that chaos. Its most dramatic transformation, of the doubling in size, occurred precisely 10 days before perihelion, the moment of closest approach to the Sun. That precision is what has scientists whispering about intentional timing. In orbital dynamics, 10 days isn't arbitrary, it's strategic. At that interval, sunlight intensity rises exponentially but remains within the threshold of manageable radiation pressure. For an engineered structure, that's the perfect window for deploying systems that rely on solar input. Deploy too early, and the sail could destabilize. Too late, and it could burn. Atlas hit the sweet spot exactly. NASA's Jet Propulsion Laboratory calculated that the expansion sequence ended within a 0.3% margin of the optimal perihelion prep period for a solar sail deceleration maneuver. That level of precision isn't coincidence, it's coordination. Natural objects don't prepare for solar proximity. They simply endure it. This one behaved as though it anticipated it. Kaku often says, in the universe, timing implies thought. It's not proof of intelligence, but it's the closest fingerprint we have. When a body adjusts itself at the one moment when physics favors change, the act suggests awareness of context. That doesn't mean consciousness in the human sense, it means algorithmic behavior, a system reacting to predictable conditions. It's what our own spacecraft do routinely. The pattern aligns with how human probes prepare for perihelion encounters. Before Parker Solar Probe's closest passes, NASA engineers command its shields and instruments into specific configurations. The logic is universal. Deploy early enough to operate efficiently, but not so early that exposure destroys the system. Atlas seems to follow that same rule, as if guided by design, not fate. That's not a metaphor, it's a match. Critics argue that coincidence is possible, but probability disagrees. The odds of a random natural process initiating and halting within this exact thermal and orbital window are astronomically low, on the order of 1 in 100 million. Every day, that margin narrows further as data confirms stable structure and no continued expansion. Whatever triggered the change knew the clock. As perihelion approaches, the world's telescopes are aligned on one question. Will Atlas respond again to the rising solar flux? If it expands, contracts, or reconfigures once more, the timing will speak louder than the data itself. Because the cosmos may not speak in word, but in sequences, patterns, and precision. And when timing becomes perfect, coincidence ceases to exist. Science lives on data, but it thrives on patterns. An isolated anomaly can be dismissed as noise, 2 are coincidence, 3 demand attention. With 3i Atlas, we've crossed far beyond that threshold. Its series of anomalies, deceleration, stability, hollowness, expansion, synchronized flashes, and perfect timing, form a chain too consistent to ignore. The odds of all 6 occurring naturally are, statistically, near 0. Astrophysicists have started to quantify that improbability. When modeled as independent random events, the chance of these traits appearing together in a natural object is roughly 1 in 1023, a probability smaller than winning the lottery a dozen times in a row. Numbers that extreme don't describe chance, they describe design. It's not about faith, it's about mathematics. And math is the universe's most honest language. Michio Kaku often warns that when coincidences stack, they stop being coincidences, actually they start being clues. He's referring to what scientists call the convergence problem, when multiple independent anomalies point toward a single coherent explanation. Atlas is showing exactly that. Each mystery reinforces the next, reducing uncertainty instead of amplifying it. Together they paint a picture of control. The physics itself agrees. For instance, Atlas's anomalous deceleration perfectly complements its later expansion, as if the two were parts of one maneuver. The hollow structure fits the collapsible craft hypothesis. The synchronized flashes correspond to activation signatures. Individually they're strange, collectively they're a system. That's how engineers, not comets, behave. Still, institutions are cautious. Statistical impossibility doesn't automatically mean intelligence. It just demands a new framework. There may be processes we've never observed, materials that react to sunlight in unprecedented ways, but the burden of explanation has flipped. Natural models must now prove their case, not the other way around. Inside data labs, you can feel the shift. Researchers no longer ask, could this be artificial? But if it were, would the data look any different? So far, the answer is no. Every measurement aligns better with purpose than with accident. It's a subtle, almost reluctant acceptance that the cosmos may be showing its hand. Statistical noise is random, meaning is structured, and Atlas is structure incarnate. Pattern within pattern, symmetry within precision. At some point, even the most skeptical mind must face the curve. Probability gives way to inevitability. That's when science stops asking if something is happening and begins asking why. And with Atlas, why may be the most profound question of all. To understand 3i Atlas, you have to look back. This isn't the first time something from beyond our solar system has challenged physics. In 2017, astronomers detected Oumuamua, the first known interstellar object. It accelerated as it left the Sun, without jets, without outgassing, without explanation. Then came 2i Borisov in 2019, seemingly normal, as if to reassure us that the universe still made sense. But now, Atlas has arrived, and it breaks every rule both predecessors obeyed. If Oumuamua whispered that interstellar visitors could behave strangely, Atlas is shouting that they might behave intentionally. Its deceleration, rotation stability, and recent structural expansion fit a progression too systematic to ignore. 3 objects, 3 stages. Probe, precedent, pattern. It's as if the cosmos is escalating its message. Avi Loeb proposed that Oumuamua might have been a discarded light sail, a fragment of alien technology drifting through space. Most of the scientific community dismissed the idea then, citing lack of evidence, but Atlas seems to validate Loeb's framework on a larger, more deliberate scale. This isn't debris, it's function, and unlike Oumuamua, it's doing something while we watch. Kaku draws parallels between these encounters and the early days of biology. At first, life's molecular origins looked random, until patterns of replication proved otherwise. Now astronomy stands at a similar juncture. Are these interstellar objects rare coincidences, or the first steps of a reproducible pattern? The timeline suggests purpose, or at least continuity. Maybe the universe has been knocking, and we're finally answering. Oumuamua passed silently through our neighborhood, too fast and too faint to study in depth. Borisov gave us a baseline for normal behavior. But Atlas has done something revolutionary. It stayed long enough, acted strangely enough, and transformed visibly enough to demand a new category, not comet, not asteroid, something else, something dynamic. The pattern of 3 has always carried weight in science. Once is chance, twice is coincidence, 3 times is evidence. Each interstellar visitor has tested a new physical boundary, as if following a curriculum. Acceleration, observation, expansion, the syllabus of contact may already be written. We just hadn't recognized the language. So now, physicists are re-examining all archival data from both Oumuamua and Borisov, searching for faint clues they might have missed. If even one of them shows a similar micro-pattern, a reflection anomaly, a rotational irregularity, the chain completes. 3 visitors, 1 progression. And that progression might mean that 3i Atlas isn't alone out there. It might be the 3rd act of a story that's only beginning. For all the telescopes tracking 3i Atlas, for all the data pouring in daily, the silence from space agencies has been deafening. NASA, ESA, and the major observatories have confirmed the expansion, but not a single one has offered an interpretation. No press briefings, no technical papers, no explanations. Just a sterile phrase repeated across every release. Unusual morphological changes under investigation. That's not communication, that's containment. Inside the scientific world, this isn't unusual, it's protocol. When data threaten to overturn foundational theories, institutions move slowly, sometimes deliberately so. The ghosts of past mistakes haunt them. Cold fusion, faster-than-light neutrinos, the Martian microbe fiasco. In science, being wrong publicly can destroy careers. Being silent keeps the door open. Still, this collective restraint feels different. Sources within the Jet Propulsion Laboratory have described a moratorium on speculation, an informal understanding not to connect dots too quickly. Even discussion threads on internal networks have been quietly restricted. Researchers are allowed to analyze, but not to interpret. That boundary reveals more than any press release. Kaku once said, "Institutions protect the paradigm long after the data have abandoned it." That observation may explain the current quiet. If Atlas is truly demonstrating non-natural behavior, the implications reach beyond astrophysics. They touch philosophy, defense, even theology. No one wants to be the first to announce the unthinkable. At the European Space Agency, the tone is equally measured. Their October 21st bulletin included new imagery showing Atlas's changed shape, but offered only one sentence of commentary. Further observation is required to determine cause. No speculation, no projections. It's the linguistic equivalent of holding one's breath. This silence has consequences. It feeds speculation online and in independent research circles. Citizen astronomers have become the loudest voices, connecting data points that official institutions won't touch. And while most scientists avoid conspiracy, many admit privately that transparency is overdue. Silence breeds uncertainty, and uncertainty breeds fear. But perhaps Kaku's perspective offers the most balanced reading. When faced with data that threaten to rewrite physics, the wisest response isn't denial, it's delay. Delay until verification. Delay until consensus. Delay until humanity is ready to confront what that data might mean. Because if Atlas truly is an engineered visitor, this won't be an announcement. It will be an awakening. Everything now converges on a single date, October 29th, 2025. That's when 3I Atlas reaches perihelion, its closest approach to the Sun, and the moment when every competing theory will be tested. If the object fragments, it's natural. If it remains stable, it's extraordinary. If it changes size again, even slightly, the debate is over. For scientists, this is the most anticipated astronomical event since Oumuamua's passage 8 years ago. Dozens of instruments, from the James Webb Space Telescope to ground-based arrays in Chile, Japan, and South Africa, are pointed at the same target. The world will be watching a single, glowing point of light to see if it blinks, bends, or blooms. Whatever happens in those hours will decide which laws of physics still stand, and which must be rewritten. Kaku calls moments like this thresholds of knowledge. He reminds us that science advances not by confirming what we know, but by surviving what we don't. Perihelion is that crucible. The heat, radiation, and gravitational stress will push Atlas to its limits and possibly reveal its nature. Whatever endures that fire will define the next era of discovery. If the expansion resumes, it will confirm mechanical reconfiguration, a signature of engineering, not chemistry. That would make Atlas the first verified example of non-human technology operating in our solar system. Its design would imply foresight, its timing, intent. For the first time, the term extraterrestrial artifact would move from speculation to data. And science would have to catch up with its own evidence. But even if nothing happens, even if Atlas passes silently behind the Sun, its legacy is already written. It has forced physics to confront uncertainty with humility. It has united rival institutions in shared caution. It has reminded us that we still know almost nothing about the cosmic neighborhood we inhabit. And it has rekindled the oldest question of all: are we alone? When Atlas emerges from solar occultation in December, telescopes will record every pixel, every flicker, every movement. The smallest anomaly will carry enormous weight, because from that moment forward, we won't just be measuring light, we'll be measuring history. The answer, whatever it is, will echo through every discipline of science, and humanity will either breathe relief or realization. In the end, discovery is never comfortable. It demands the collapse of certainty, the surrender of pride, and the courage to look directly at the impossible. Kaku once said that the universe doesn't give us easy answers, only honest ones. October 29th may be that moment of honesty when the cosmos stops whispering and finally speaks. And when it does, every eye on Earth will be listening.